Shh. We're now being recorded.
Hooray.
Keep your conversations to a minimum. All right. So again, what do we know about a parabola? What do we know about the graph? Let me be a little bit more specific. What do we know about the graph of a parabola? Okay, what do we know about the graph of a parabola? It's got that rounded shape to it, right? So that being said, if you ever get something that looks like this, you done messed up, right? That usually means that you've not put parentheses in the correct spots. Okay. What other things do we know about a parabola? Okay, it's a U shape. Now what? What else have we learned about a parabola? We've learned a lot of things. Well, up or down. How do you know whether it goes up or down? Right. If there's a negative in front, where does it go? Downward, right? If there's a positive in front, then it goes upward. Yes, sir. It has a vertex. Good. We can find the vertex. What's another key part of a parabola? What do you find first to find the vertex? The axis of symmetry, right? Okay. What else do we know? What did we learn? The very first thing that we learned in section 9.3 or 9.2, excuse me. What do you call where it crosses the x-axis? The zeros. Now, we won't be really talking about them today because does every parabola have zeros? No, some don't. Okay, we're going to get into that like in section 9.5 and 9.6. Okay, so we've learned a lot about parabolas. We've learned a lot of key information. So all we're going to do today is kind of put that all together. Everything that we've learned in section 9.1 and 9.2, we're going to put together so that we can graph in section 9.3. All right. Now, the one new thing that we will learn is the Y-intercept. Guys, the Y-intercept is the easiest part of graphing a parabola. How do you find any Y-intercept? What comes to mind? Maybe slope-intercept comes to mind? Like if I had said, stop it. If I had said y equals mx plus b, what's the Y-intercept? B, right? Why is it b? We talked a lot yesterday and the day before about the zeros being x comma 0. Well, what's a Y-intercept then? 0 comma y. So that means if I plug in 0 into the equation, that's our Y-intercept. Watch what happens if I plug in 0 here. I would get y is equal to m times 0. What's m times 0? 0. And then what's 0 plus b? B. So our Y-intercept is 0 comma b. Now that was for slope-intercept. That was for lines. Now we're in a different world here, right? We're in curves. So does that rule still apply? Yes, that rule still applies. What would happen if I were to plug in into this equation? If I were to plug into this equation 0, y equals a times 0 squared plus b times 0 plus c. What would I get then? What happens to this? 0. What happens to this? What's left? C. So what I'm telling you is that the Y-intercept is always 0 comma c. 0 comma c. So where do you look to find your c value? Where is your c value? Always the last number of the equation. That's why we've been writing it down so many times. Because guess what, folks? That's your Y-intercept. That is your Y-intercept. There's no calculations you need to do. There's no formulas you need to do. That is your Y-intercept. So 3 pretty easy examples that we got here. Look here. What's my C term? What's weird about this first one? It doesn't have a B term, right? It doesn't have a B term. Well, that's okay. The B term would just be 0. But the C term is -2. Do you see how it crosses the Y-axis at -2? What's my C term here? Notice how it crosses the Y-axis at 4? What's my C term here? Notice how it crosses the Y-axis there? Okay. that last number on the end will be your y-intercept. Okay, so again, now we can add that into the mix. So here's how we're going to graph a parabola. Now I have it laid out for you, step by step on what to do each time. Okay? But this is all that we know. We know how to find the axis of symmetry. We know how to find the vertex. Now we know how to find the y-intercept. The last couple things is, well, I might need some more additional points, but we've got to strategically pick those points. Okay, is everybody listening to me? Are we listening? Yes, hi. We have to strategically pick those points. We have to pick them on the same side of the parabola as the y-intercept. I know that seems kind of weird, like what are you talking about? It'll make more sense when we do one. And then what do? We reflect points and graph. So let's try one, shall we? This is your number one as well, right? Okay. Now, first off, there's not a blank for it, but do we know whether it opens upward or downward?
Yes.
What does it do? We know that it opens upward. Okay. So if I go and I graph and it opens down, uh-oh, something's going wrong. You done messed up.
You done goofed.
You done goofed. All right, so what is A? Let's start by identifying A, B, and C, because we'll need all terms. What's A, B, and C? Mallory, what's A, B, and C?
A is 1, B is 2, and C is -3.
Good. Now, my first blank says find the axis of symmetry, and I am nice enough to even give you the formula. So we say x equals -2 divided by 2 times 1, or just 2. So what is the axis of symmetry? What is the axis of symmetry? X equals -1. Thank you. X equals -1. Remember, I'm going to be picky. Okay, so make a dotted line down -1. Hey, what kind of pants does Mario wear? Denim. Denim.
I don't get it.
Underground levels.
It's the underground line. Come on, guys. 1, 2. All right. Shh. Now, how do I find my vertex now? How do I find my vertex? Caroline, how do I find my vertex then?
-1 into all axes.
So let's do it. So we've got -1 squared plus 2 times -1 minus 3. We know that we're going to get a coordinate -1 comma something. So let's plug it into our calculators. -1 squared plus 2 times -1 minus 3. -4. That's a message. If you got anything else other than -4, you put it into your calculator wrong. Okay? Now, let's plot that point. -1, -4. Where's our y-intercept? This is the new thing for today. Where's the y-intercept? -3. I'd like us to even go so far as to say 0, -3. And we plot that. Remember, the y-intercept is on the y-axis. Okay, now, it says 2 other points. That means I need to make a table of values. I need to make a quick table of values, but I don't need to do all 5. I just need to do 2. But they need to be a particular 2. Guys, let me ask you a question. Look at the axis of symmetry. You're standing on the axis of symmetry. Which side of the axis of symmetry is the y-intercept on? Is it on the right side of the axis of symmetry or the left side? It's on the right side. So you need to pick 2 more points on that right side. Pick 2 more x values on the right side of the axis of symmetry. Okay, so I'm sitting here at -1. What's the next number to the right? 0, but I've already found 0. What's the next number to the right? What's the next number to the right? So that's how we pick those points. Okay, we're standing on the axis of symmetry, we're standing at -1. We look to the right, we see 0, but 0, -3 is already solved for us. We don't want to do that one again. So we go even one step further to the right, we go +1. One step further to the right, we go 2. Now we just plug those two values in. So we've got 1 squared plus 2 times 1 minus 3 to get 0. And we plug in 2. 2 squared plus 2 times 2 minus 3, we get 5. Is everybody following me there? So now we plot those 2 points. 1, 0, 2, 5. Now, we see the full right arm of the parabola. What do we know about the left side of the parabola? It has to be exactly symmetrical, right? So that's all we're going to do. I'm just going to reflect all those points over. Okay, going from my axis of symmetry, do you notice how this point is 1 unit away? So I'm just going to go 1 unit on the other side, make a new dot. Notice how this point is 2 units away? So I'm going to go 2 units away on the other side, make a dot. This point is 3 units away, so this point needs to be 3 units away, make a dot. And guess what? There's my full left side of the parabola. Do I need those little lines in the middle? No, you don't. I'm just putting in there so you see where I'm getting those values. That make sense? And that's how we graph a parabola. Can we do that again? Yes, the answer to that question is, of course we can, Mr. Laver. Guys, remember, you should always double check. Your vertex should be on that dotted line. Right? Your vertex should be on that dotted line. I'm going to give you guys a head start here. Identify A, B, and C. And start calculating your axis of symmetry. Yeah, I got you. Yeah, it might be like a week.
Okay, thank you.
Okay, so we know that A is -2, B is -8, and C is +10. So my axis of symmetry is x equals, now this is +8 over 2 times -2, or 8 divided by -4. Did you all get -2, x equals -2? If you got +2, go back and check. There's actually all 3 negatives. The negative that's out in front of the equation. A value is negative and B value is negative. So 3 negatives total, 2 of them cancel out, leaving 1. So that's why my axis of symmetry is negative. I make a dotted line at -2. No. It's kind of off a little bit. So I'm going to do this. There we go. And now we calculate the vertex. It's at -2 comma something. So let's just see what that something is. We plug it in. We say -2 times -2 squared minus 8 times -2 plus 8. Did you guys get 18? If you didn't get 18, check your work there. Now, that's pretty high up. Is this going to open upward or downward? Okay, good. So this parabola is going to fit on my graph. If it opened up, oh, life was going to be hard. But it opens down, so we're good. What's our y-intercept? +10, 0, comma 10. Right there. Okay, now let's make our table of values. Again, strategically picking our table of values. Guys, where is our axis of symmetry? It's at -2, right? Okay, so we're sitting at -2. The y-intercept is on the right side. Now, what's the next number? We're sitting at -2. What's the next number to the right on the number line? -1. Have I calculated -1 yet? No. What's the next number to the right? Okay, we've moved to -1. What's the next number over? Have we calculated 0 though? Yes, we have, 0, comma 10, right? So then we move to the right one more unit, 1. And we already had 0, so now we move up to 1. Let's run those two values. So we have -2 times -1 squared minus 8 times -1 plus 10, 16. And then we have 1, -2 times 1 squared minus 8 times 1. Whoa, that's 11. Plus 10. Okay, 0. -1 comma 16 and 1 comma 0. I'm just putting a semicolon in between there just to separate them. You don't really, that's not really like a must have. And now we plot those points, -1 comma 16 and then 1 comma 0. So do we see the full right side of the parabola again? So let's reflect over all those other points. Point here, a point here, and a point here. And that's the full left side. Questions about that? Okay, our last problem is our dolphin jumping out of the water problem. Now, what path do you think a dolphin is going to make when it jumps out of the water and then back down again? A parabola, right? Remember, why is it making a parabola? Because gravity is constantly pulling it back down again, right? Up and down. So it's going to be a nice, even curve, right? Now we're excluding like wind resistance and air resistance and things like that. But in a perfect world, it's just going to go up and then back down again. Nice parabolic shape. Gravity is always pulling it down, okay? So, dolphin jumps out of the water. It's modeled by this function, -16 x squared plus 32.
What was that?
Sorry.
It was a dolphin.
Oh, a
It
dolphin.
sound- like, honestly, I was like, what kind of animal noise was just made right there? There's a Yeti in the room. No pun intended.
That wasn't even.
Last.
See what I did?
I thought that was really funny.
That was
Yeti.
I thought it was pretty funny. I understand.
Oh,
Okay,
Sorry.
so we got -16x squared plus 32x, where x is the time in seconds it takes to jump, and y is the maximum height. Find the dolphin's maximum height. Guys, what am I asking for when I say maximum height? The vertex. I'm asking for the vertex, so let's find the vertex. Guys, do I need to identify C? What is C in this case? Is there a C value? No, so what is it? 0, right? 0. So negative 16 is my A, and 32 is my B. So x equals negative B over 2A, which means negative 32 divided by 2 times negative 16. Well, 2 times negative 16, negative 16 is 2 times negative 16 is negative 32. So what is my axis of symmetry? X equals 1, right? Okay. Now, is that my answer? It goes 1 foot off the ground? No. What do I need to do with that 1? Plug it back in. So we say negative 16 times 1 squared plus 32 times 1, which gets us 16. Plug that in my calculator. Negative 16 plus 32 is 16. Okay. So what's the maximum height? What's the maximum height? 16 feet. Now, how long does it take to get there? Let's graph this. At 1 second, it's 16 feet. Right? So, whoop. And we know that axis of symmetry is sitting there at 1. Go ahead and draw this in with me. So how long did it take the dolphin to reach the maximum height? 1 second. How long is it totally in the air then? 2 seconds, right? Because we know that's the axis of symmetry. So we know it must be parabolic. Whoa, sorry, my right side's a little bit wonky. So 2 seconds total in the air. If it takes 1 second to reach the vertex, the midway point, then it will take another second to come down. Always equivalent on either side. Questions about that? All right, everybody say bye to YouTube.
It's been on, so. Bye, YouTube.
So long.